Hey, all, today we're going to talk about categorical data. That is data that is unitless, data where we can take our participants or our subjects and put them into their responses into categories. And we're going to talk about how we can display categorical data and how we can sort of read some of those displays. It's really important that when we are displaying anything that we collect, and I'm sorry, I'm noticing this is a bit blurry, but you might get the idea of what you are looking at, hopefully, that we follow this thing called the area principle. And that means that the area of the display, whether we are using a bar chart or a pie chart, which we'll look at, which you probably are already familiar with, that the pieces of those displays, the area represents the amount of respondents or the amount of subjects in that category. And so the picture on the left here represents a voting map. I'm not totally sure of the election year, a long, long time ago. The red states represent states that voted Republican, and the blue that voted Democrat. And this picture is a bit misleading because we have just put them on there as they are geographically, but that doesn't necessarily represent the number of electoral votes. And so this display on the right has sort of manipulated the map of the United States so that each state is sized to represent the number of electoral votes. And you can see how in the left picture there looks to be way more red than blue. But when we look at the right picture, sized based on the number of electoral votes, that there is probably more blue there. And so you can see how if we display data inappropriately, it can be very misleading. Bar charts are probably something that you have been used to. We represent counts on the vertical axis, frequency or counts. The bars do not need to touch each other because this axis is not numeric. It's just representing our categories. So this is people on the Titanic who are either in first class, second class, third class, or on the crew. Again, I'm sorry if this is a little blurry. I will adjust for that in future lessons. And so these are just different ways to represent which class you were in or were part of on the Titanic. This is counts or frequency, the actual number of people. This is in percentage out of the whole. Here we have what's called a side-by-side bar chart, where we broke each category down based on whether or not that person survived or died. And then here we have a segmented bar chart where this bar represents those who lived, and this bar represents those who died. And so each of these parts of the bar represent the proportion of people in each class, first, second, third, or crew. So these percentages show you a percentage of this category, and these bars or pieces show you percentages for each category for those who died. And you can see they both go up to 100. Or hopefully you can see that's 100. We can display categorical data in pie charts. Again, this is counts, just showing the piece of the pie, so to speak, that the crew and the first class and second class and third class. So you can see that the crew made up the largest chunk of the pie. Third class was pretty close. Here we've broken that up into those who lived and those who died. I apologize for the depressing example. And so this is just another way to display the amount of people, the amount of subjects in the different categories. Again, I believe things that you will have seen before. But now let's talk about contingencies tables. This is another way to display categorical data. Here we have two categories that we are displaying together. We have gender and eye color. Gender and eye color. Just talking sort of about the anatomy of this contingency table. We have the two parts of the category gender, male, female. Just on this study and what they studied. Then we have the types of eye color they were interested in, blue, brown, and then basically other. And then we have these margins where we get the totals from each row and each column, and then 64 would be the total of number of people that we discussed. And so we can pick information off of this table to answer some of these questions. We want to know the percentage of people that are blue-eyed. What percent of people are blue-eyed? So that would be, we want to look at all the people that are blue-eyed. There's 10 of them. And there was 64 total people. And we can turn that into a decimal if you want to. That's a proportion. We can turn it into a percentage. Typically, when we turn things into decimals, I like to round to 4 decimal places. So if you're working through this, you can pause, turn that into a decimal. But for time's sake, we're going to use the fractions. We want to look at the percent of females that are brown-eyed. We can look just at the females. What percent of females are brown-eyed? There's 16 females who have brown eyes out of 32 total females. And so that one's kind of easy. That's 0.5. So 50%. We want to know what percent of brown-eyed students are female. We're going to look just at this column. We're just going to look just at the brown-eyed students. This is sort of a condition we've set. We only want to look at the brown-eyed students. There are 36 of them, and there are 16 females. And this will be a different percentage than 50%. It'll be a little smaller. Another thing we can look at in these contingency tables are distributions. Distributions are basically, for example, for the males, if I look at all 32 males, how is the color of their eyes dispersed amongst those male subjects? For our margins, which are down here, we would be looking at how are the eye colors in general dispersed amongst all of our subjects. So we will go take our totals, 10, 36, 18, and divide those by the total number of participants or subjects. And we would convert them to percentages. So I invite you to pause when I'm done here, convert these into percentages, and these three values represent the distribution in that margin for eye color. Similarly, we can find the marginal distribution for gender. Now, I might be going fast. Make sure you pause or rewind. This is the same information. We are now just going to fill out the margin for gender. Again, 64 total participants, 32 male, 32 female. And so that's relatively easy. The distribution is 0.5 and 0.5. So they are evenly distributed. The participants are evenly distributed amongst the two genders that we studied. So similar to what I started with when we were talking about marginal distribution, we can find conditional distributions. So we can find the distributions of eye colors based on the condition that we want to look at those based on your gender. So we can find the distribution of eye colors for males. And so then we would take the total number of blue and divide by the total number of males. And then brown and other. And we can do the same thing for females. So we're seeing how the eye color is distributed with the condition we're only look at male participants. We could also look at to see how the eye color is distributed if we're only looking based on the condition that we are choosing the female participants. And again, we could convert those to decimals. Rounding to 4 decimal places is the best thing to do. But again, for time's sake, I'll let you either do that on your own, or we can follow up in other problems using decimals. We can do the same thing if we want to isolate one color eye and see how the genders are distributed across that eye color. And all of this would be to figure out if there is some relationship between gender and eye color. That's something we'll talk about in the future, but the point of doing these distributions is to determine if there is a relationship between gender and eye color. So if we are isolating one color eye, we would do the number of male blue eyes divided by the total number of blue-eyed individuals. That's 10. Same thing with brown eyes. And then the other colors. So I want you to give this one a try. Let me pause real quick and rewrite these numbers in case they're blurry. So here we have some data from a parking lot at a school. We have the type of driver classified, whether that driver was a student or a staff member, and then the origin of the vehicle, whether it was American made, made in Europe, or an Asian made vehicle. And so what I'm asking you to do is to calculate the marginal distribution for the origin of cars and calculate the conditional distribution of the two types of drivers. If you need some help, you can work together. You can definitely ask me for help, and then we will discuss this you do problem at the beginning of next class. Take our time on this, ask for help if needed, and good luck.